In this video, we are going to solve question number 2 of exercise 1.2. The question is, find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equals to the product of the two numbers. So let's try to solve the subparts. Now this is the first subpart of question 2. We need to find out the prime factorization of 26 and 91 and find out their lowest common multiple and highest common factor. Let's try dividing 26 first. So if you will divide it with 2, we are going to get 13 as a quotient. Again, 13 is a prime factor, so let's divide it with 13. We are going to get 1 as a quotient. Now, what about 91? So we can divide 91 with 7. That will give us 13 as a quotient. 13 is again a prime number, so let's divide 13 with 13 in order to get 1 as a quotient. So therefore, we can write down 26 as 26 is equals to 2 into 13. Now, this can be written as 2 raised to 1 into 13 raised to 1. Again, 91, we can write down it as a product of prime factors as 7 into 13. Observe, it can be written as 7 raised to 1 into 13 raised to 1. Now, what would be the HCF, highest common factor of these two numbers? So, we have to write down the least exponent possible in both the numbers. So, observe, for prime factor 2, if you will see in 26, we have a prime factor of 2, right? 2 raised to 1. But in 91, we don't have that. So, we will be writing 2 raised to 0 because 0 is the least exponent possible. Similarly, 7 is appearing in 91 as a prime factor, whereas in 26 we don't have 7 as a prime factor. Therefore, we will be writing 7 raised to 0 over here. And since 13 is occurring in both of them once, therefore we will be writing 13 raised to 1. And hence our HCF here would be 2 raised to 0 into 7 raised to 0 into 13 raised to 1, which is equals to 30. Because anything raised to 0, any positive number or negative number raised to 0 will be giving us 1 as its value. So therefore 2 raised to 0 will be 1, 7 raised to 0 will be 1, multiplied with 13 raised to 1 will give us the entire highest common factor as 13. Now let's find out the lowest common multiple over here. So for lowest common multiple, we will be writing the highest exponent possible. So observe, in 26 and 91, 2 is occurring once in 26, right? So highest exponent possible for 2 would be 1. Similarly, in 91, 7 is occurring once. So we will be writing 7 raised to 1 here. For 26 and 91, 13 is occurring once in both of them. So we will be writing 13 raised to 1. And hence our LCM will be equals to 2 raised to 1 into 7 raised to 1 into 13 raised to 1. The product of all these three numbers will give us 182 as the lowest common multiple. Now we will be finding out the product of these two numbers. 26 into 91 will give us 2366. And the product of HCF and LCM is equals to 13 into 182, which will be again 2366. So what did we conclude? We have verified that product of the two numbers is equals to HCF into LCM. So with this, we are able to verify that the product of two numbers is equals to the product of their LCM and HCF. Now this is the second subpart of question number 2. Here, let's prime factorize 510 first. So we will be getting, on dividing this number with 2, we will get 255 as a quotient. And now we can divide it with 3 because the sum of 255, 2 plus 5 plus 5 will give us a number which is divisible by 3. 2 plus 5 is 7, 7 plus 5, you are going to get 12, right? 12 is divisible by 3. So therefore, this entire number 255 is divisible by 3. Now, if we will divide it with 3, we are going to get 85 as a quotient. And now this 85 is neither divisible by 2 nor 3. So we will divide it with 5. Since the unit place of this 85 is 5, therefore it is divisible by 5. If we will divide it, we will get 17 as a question. Now 17 is again a prime factor, so we can divide it with 17. We are going to get 1 as a question. So we have done the prime factorization of 510. Let's try dividing 92 now. Let's try to do the prime factorization of 92. So since 92 is an even number, we can divide it with 2. Therefore, we are going to get 46 as a question. And again 46 is an even number, we can divide it with 2. We are going to get 23 as a question. Now 23 is a prime number itself. So therefore, we are going to divide it with 23 only, and we are going to write down 1 as a question. And now we will be writing down 510 as 2 into 3 into 5 into 17. So we can observe that every factor here is occurring once. So we will be writing 2 raised to 1 into 3 raised to 1 into 5 raised to 1 into 17 raised to 1. Now let's write down 92 as a product of the prime factors. We will be writing 92 equals to 2 into 2 into 23, which can be written as 2 raised to 2 into 23 raised to 1. Now for finding out highest common factor, we will be writing the least exponent possible in both the numbers for that prime factor. Here in 510, we can see 2 raised to 1. In 92, we can see 2 raised to 2. Therefore, the least exponent possible would be 2 raised to 1. Similarly, for 3 is occurring as a prime factor in 510 but not in 92. So, therefore, the least exponent for 3 would be 0. We will be writing 3 raised to 0. Same happens for 5. 5 is occurring in 510 but not in 92. So, therefore, we will be writing 5 raised to 0. And same applies for 17 also. 17 is occurring as a prime factor in the prime factorization of 510 but not in 92. So therefore the least exponent possible for 17 would be 0, and hence we will be writing 17 raised to 0. Same happens for 23. 23 is occurring in 92 as a prime factor but not in 510. We cannot see the prime in the prime factorization of 510, we cannot see 23 at all. So therefore the least exponent possible for 23 will also be 0, and hence we will be writing 23 raised to 0. Now if we will try to multiply all these values, 2 raised to 1 into 3 raised to 0 into 5 raised to 0 into 17 raised to 0 into 23 raised to 0, these all values 3 raised to 0 into 5 raised to 0 into 17 raised to 0 into 23 raised to 0 will give us 1, and multiplying it with 2 raised to 1 will lead us to 2. Now let's talk about what is LCM of these two numbers. So for LCM, we will be writing the highest exponent possible in the prime factorization of both the numbers. So here we could see that for 2, the highest exponent possible in 510 it is 1, and in 92 it is 2. So therefore we will be taking the highest exponent, that is 2. And for 3, it is occurring in 510 but not in 92. So therefore the highest exponent possible would be 1. Now let's write down lowest common multiple. So for lowest common multiple, we will be looking at the highest exponent possible. So if you will look carefully, for 2 it is occurring twice in 92 but once in 510. So therefore the highest exponent possible is 2, and hence we will be writing 2 raised to 2 here. Now for 3 is occurring once in 510 but not in 92. Therefore we will be writing the exponent, the highest exponent of 3 as 1, and hence it will be written as 3 raised to 1. For 5 also we will be writing 5 raised to 1. It is coming as a prime factor in 510 but not in 92. So therefore we will be writing 5 raised to 1. For 17 again, we will be writing 17 raised to 1 as it is occurring once in the prime factorization of 510 but not in 92. Same happens for 23. It is occurring as a prime factor in 92 but not in 510. So therefore, we will be writing 23 raised to 1. So what did we conclude? While writing down the HCF, we look for the lowest exponent, right? Least exponent. But while writing down the lowest common multiple, we look for the highest exponent possible for both the numbers. Now, if you will try to multiply all these numbers, we are going to get 2 raised to 2 into 3 raised to 1 into 5 raised to 1 into 17 raised to 1 into 23 raised to 1. So, this entire product will give us 23,460 as the lowest common multiple. Now, the product of the two numbers is equals to 510 multiplied with 92, which is equals to 46,920. And the product of their HCF and LCM is equals to 2 into 23,460, which will give us 46,920. So what did we observe? We got the same value in the product of the two numbers as well as the product of their HCF and LCM. So what did we observe? We got the same value while doing the product of the two numbers and the product of their HCF and LCM. So we will be writing finally that we have verified product of the two numbers is equals to the product of their highest common factor and lowest common multiple. Now this is the third subpart of question number 2. Here we have to find out first of all the prime factorization of 336. We have to divide it with 2 since it is an even number. So now we are going to get quotient as 168. And if you will divide it again with 2, since 168 is also an even number, if you will divide 168 with 2, we are going to get 84 as a quotient. Again 84 is an even number, so we can divide it with 2 in order to get 42 as a quotient. Now let's try dividing 42 with 2 since it is an even number, so we are going to get 21 as the quotient. Now 21 is an odd number, so now we will be dividing it with 3. Since the sum of 2 plus 1 is equals to 3 and 3 is divisible by 3. So we will be dividing 21 with 3 in order to get 7 as a quotient. And now 7 is a prime factor, so we can divide 7 with 7 in order to get 1 as a quotient. Now we are left with 54. So let's prime factorize 54 also. If we will divide 54 with 2, we are going to get 27 as a quotient. Now since here 54 is an even number, we first of all tried dividing it with 2. Now 27 is an odd number, so we can divide it with 3 because the sum of 2 and 7 will give us 9 and 9 is divisible by 3. So therefore we will divide 27 with 3 in order to get 9 as a quotient, and hence we can divide 9 with 3 in order to get 3 as a quotient. Finally we will be dividing 3 with 3 in order to get 1 as a quotient. So therefore now we will be writing 336 and 54 as the product of their prime factors. 336 is equals to 2 into 2 into 2 into 2 into 3 into 7, which can be written as 2 raised to 4 into 3 raised to 1 into 7 raised to 1. Also 54 we can write it down as 2 into 3 into 3 into 3. And here this can be written as 2 raised to 1 into 3 raised to 3. Now for HCF, highest common factor, we will be writing down the smallest exponent possible in both the numbers for that particular prime factor. So if you will observe, 2 is occurring 4 times in 336, whereas in 54 it is occurring only once. So therefore we will be writing 2 raised to 1 here. Same for 3, it is occurring once in 336 but thrice in 54. So therefore we will be writing 3 raised to 1. Now in 336, 7 is occurring once but not at all in 54. So therefore we will be writing 7 raised to 0 here. If we will multiply 2 raised to 1 into 3 raised to 1 into 7 raised to 0, we are going to get 2 into 3, which is 6. And now we will be finding out the lowest common multiple. So for lowest common multiple, we will be looking at the highest exponent possible, right? Now here for 336, the highest exponent of 2 is 4, right? Here it is 1 and over here you can see it is 4. So therefore we will be writing for 2 raised to 4. The exponent we will be writing it as 4. Now for 3, what about for 3? Here it is occurring once, 3 raised to 1, whereas here it is occurring thrice. So we will be writing 3 raised to 3 over here. Now for 7, it is occurring once here in 336 and not at all in 54. So therefore we will be writing 7 raised to 1. Now if we will multiply all these values, 2 raised to 4 will give us 16, 3 raised to 3 will give us 27 and 7 raised to 1 will give us 7. So if we will multiply all these values together, we are going to get 3024 as the product. Now if you will find out the product of the two numbers, that is 336 with 54, we are going to get the product as 18,144. Now let's check whether the product of the HCF and LCM is it the same or not. So if you will multiply highest common factor with lowest common multiple of these two numbers, we are going to get 6 into 3024, which would be 18,144. Now here we observe that we are getting a same number, right? If you will multiply the two numbers 336 with 54, we are going to get the same number as we are multiplying the product of their HCF and LCM. And hence we can write down the product of the two numbers is equals to their highest common factor into their lowest common multiple.